Welcome. This is the second in a video training series featuring Azure Data Technology. In the first part of the series, we covered some common terms and definitions and the storage options. In this part, we'll cover ETL, hubs and caches, and the SQL Server options. In later parts, we'll be covering the graphical databases, NoSQL databases, analytics, big data, and a few other options. So let's get started. We started with this particular slide last time. The purpose of the entire series is to demystify drawings like this that have many different components from the Azure data stack. Until you're familiar with what each component does, it's difficult to understand what drawings like this really mean. So hopefully after part one, this looks a little better as we covered some of the storage options, and hopefully with this part, it'll demystify the diagrams like this even further. So with the ETL tools we have available in the Azure Data Stack, we have the Azure Data Factory, Azure Synapse Pipelines, Event Hubs, and IoT Hubs. So let's talk about each one of those in more detail. Now this is really intended to be more humorous than informative. This is an infographic on just the Azure Data Factory. These videos are covering each of these components at a high level, but this slide can give you an idea of exactly how complex one of these components can be when you dive down. And so we'll just talk about Azure Data Factory at a much higher level than this, but I wanted to show this because in my research this drawing just kept coming up over and over. And if you want to go find this out on the web and look at it in more detail, there's some very high resolution copies available at sketchthedocs.dev. Azure Data Factory is an ETL PaaS service, and you'll remember from part one of this series that with IaaS, or infrastructure as a service, we're dealing with virtual machines. With PaaS, we're dealing with the platform as a service. So here we have a platform that is configurable to do a job without needing to configure the computer that it runs on, virtual or otherwise. We simply have access to the service through the Azure portal, so we can create and schedule new pipelines. So we should talk about what's a pipeline. That's just an instance or a schedulable object that defines a data flow. We're going to set up pipelines to move data, transform data, and different steps within that pipeline are going to do the work for us as we define them. Now, pipelines are easy to create, code-free. They're in Azure Data Factory. We don't need to learn the ins and outs of a particular language. We can create data flows through PowerShell or Python or other languages, so that remains an option if you're very well versed in code development. We also have access to a lot of templates in Azure for quick start to pipeline development. So if you have something that's commonly done, likely there's already a template set up. In Azure Data Factory will get you started. All you have to do is to modify a template to your specific needs. Azure Data Factory, or ADF, can host integration services packages. So if you already have a big investment in SSIS, you can very easily migrate that workload to the Azure Data Factory. One way to think about Azure Data Factory is SSIS for the cloud. There are over 90 data connectors available in Azure Data Factory. So there's every likelihood that wherever your data is currently, wherever you're moving data to, those sources can be connected through ADF. It integrates with GitHub and DevOps for team development of pipelines, and as I mentioned earlier, is programmable with PowerShell, Python, and other languages. Here's an example of a Data Factory dashboard. Note the breakdowns by data source and pipelines. Also, both tabular and graphical visualizations are customizable to your particular needs. Now here's a schematic of the Azure Data Factory and where it would sit. You have on the left cloud sources, not just Azure, but also AWS, Google, and others. You have apps that are online, Salesforce, LinkedIn, and Facebook publishes a lot of data. This shows sensors, Twitter metadata, web logs. Any data that's published likely has a way for Azure Data Factory to consume that data. And also your on-premises data that you might have currently for moving data to the cloud on a regular basis, or maybe monitoring folders for when data arrives to be moved up. ADF can consume that data, move it to a database or other tabular output. But not only that, we'll talk about NoSQL and analytics later in the series, but it can output that data to where it can be analyzed or visualized, say through Power BI or other visualization tools, not necessarily limited to Power BI, of course. As a subset of the Azure Data Factory, we have Azure Synapse pipelines. Now this looks an awful lot like Azure Data Factory once you're in the development of a pipeline. It's based on Azure Data Factory components, and features from Azure Data Factory are added to Azure Synapse pipeline regularly. But this is intended to be more closely integrated with Synapse, and we haven't talked about Synapse yet. We'll talk about that later in our analytics section. But just be aware that if you're dealing heavily with big data analytics, that you'll have components of the Azure Data Factory that are most used in analytics in that same environment. There are no Power Query activities, there are no cross-region integration runtimes. It's really best for easy transformations and integrations. The jobs can be run from Azure Data Factory when needed, so you don't necessarily have to be limited to Synapse pipelines when you're working in Synapse. Oftentimes what you're doing is just simply moving data and simple transforms that you can do within the Synapse environment. But if you need to do something more complex that only Azure Data Factory can do, you can move the workload to Azure Data Factory and then back to Synapse. And finally, there are templates also available in the Synapse pipeline, just as there are in the full ADF. So here's a look at the Synapse pipeline. As you can see on the left-hand side, you've got your different sources. There are SQL pools, tables, stored procedures, etc. from Synapse. If you were looking at a regular Azure Data Factory, you could be looking at any of the other 90 connectors available. In the middle is the blue table. That's actually a stored procedure in this case with the Synapse that's going to be executed. And you specify the analytics pools, and you can also see this procedure name and more information underneath in the properties. Moving on from ETL, we have Event Hubs. This is a data ingestion service. Event Hubs are created to receive data into your environment. They can accept millions of events per second from many different sources, can ingest buffer data, store the data, and process incoming data. They can serve the data ingestion into Power BI, Stream Analytics, Azure Storage, pretty much any component that can request the data. Event Hubs can auto-scale to match data flow. We talked about auto-scaling in the first part of this series, where auto-scaling means it's going to expand based on your workload without any human intervention. You can work with HTTPS, Kafka, Node.js, Java, Python, using Event Hubs. A lot of different options for working with Event Hubs, but keeping in mind this is ingesting data. So if you've got streaming data from a service, from outputting logs, scientific instruments, or whatever might be spewing data, Event Hub would be a way to get that data from your application into the cloud. Now we see here a schematic of streaming data being ingested by the Azure Data Hub. In this particular example, the Event Hub is making that data available as being pulled up into Azure Blob Storage, as well as being ingested by an Azure Stream Analytics pipeline. So you think again, sort of SSIS for Azure, and then pushing that on to Cosmos DB into an Azure SQL database, being visualized by Power BI or made available to mobile apps. So having a store and buffer for that information that's coming in quickly is where Azure Event Hubs comes in. It's not strictly a database, but it's an integral part of most data-heavy application scenarios. IoT hubs are a lot like Event Hubs, but there's a lot of confusion between the two. If you're ever doing a certification exam, it can be really difficult to know which to use where. Most of the answer is in the name. IoT, or Internet of Things, is what this particular hub is made for. So it's a central message hub for communication between an Internet of Things application and its attached devices. If you've got an array, maybe thousands of devices out there on the internet, sending data to your application, the IoT hub is probably going to be the way to go. Almost any IoT device can be connected to an IoT hub. Those devices will be uploading telemetry files, usage data, whatever. The big difference with the IoT hub is that there's two-way communication. There's a request reply from a controlling device from the cloud. So your application can communicate with the Internet of Things that are registered with the IoT hub. It can scale to millions of simultaneous connected devices and millions of events per second. It uses secure TLS connections with those devices, and the messages can be routed to scale out the solution, so as messages are coming in, they can be sent to many different locations in case you're using components that maybe can't scale to the level that the IoT hub and the Internet of Things can. So I think if you're ever asked on that certification exam about a hub and it comes down to the event hub or the IoT hub, this two-way communications can often be the clue which hub to use where. If you need to communicate with the sensors or the light bulbs or whatever's out there on the Internet of Things, then IoT hub is going to be the way to go. If it's only one-way communication, even with a lot of Internet Things devices, event hub might also be the answer. So here's another look at the schematic for the IoT hub to give you an idea of the sources and the targets, or the event handlers as they're called. So you can get data from blob storage as the data arrives in blob storage, or media services, Azure subscriptions, other IoT hubs, service bus, about anything that can send data to the IoT hub. And then you'll have these event subscriptions on the back end consuming this data from the IoT hub, like Azure Automation, Logic Apps, Hybrid Connections, Event Hubs, etc. So you can daisy chain these. The IoT hub can send to many different subscriptions at one time in order to scale to whatever level you would need. And there can also obviously be massive scaling needed when you're in the Azure cloud. I've already touched on this a bit, but with the IoT hub, you get two-way communication between devices and backends. It supports file uploads from devices. It's great for configuration and management of connected devices because of that two-way communication. And it has less emphasis on scale, even though it can connect to millions of devices at one time. Event hubs are big data streaming services. They can handle billions of requests per day. It's built into Databricks, Stream Analytics, Azure Data Lake Service, and HD Insight. It uses one-way communication. It receives from its service and then responds to requests for that data on the back end, usually from some other component in the Azure cloud. So with the hubs and the data factories and all the components that come before the data is actually stored, let's actually move into the first components where we're actually going to store data, like in a database. And in fact, these are the SQL Server database options that we have in Azure here first. After we speak about that, in the next section, we're going to talk about more of the other options outside of SQL Server and outside of even relational databases. So for relational SQL Server, we have IaaS, or Infrastructure as a Service, SQL Server on Windows VMs, which have the same options you have in your on-premises SQL Server because you control the VM. Then we get into the PaaS options for SQL Server. We have the SQL Server Managed Instance, which is configured to look as much like a full SQL Server as possible, but you don't have the access to the machine behind the server, so you only have the SQL service then. Then there's Azure SQL Database, which is simply a database. It's as simple a platform for data as you can get on Azure. We also have Azure Database for MySQL and MariaDB, which we're going to talk about in the next video. And then some other NoSQL options like Postgres, Cassandra, MongoDB, and Cosmos DB. Many, many options in Azure. But let's go back. I'm not going to talk as much about Azure on VMs because I think this particular audience should already know and have worked with SQL Server on-prem. And it's the same thing. You have to configure your virtual machine. You're just configuring it in Azure. You configure the storage, configure the memory, etc. So that's one option. The first option we're going to be looking at is going to be the Azure only option, is Azure SQL Database. Now this is a fully managed database engine, meaning Azure is doing the backups, it's doing the upgrades, and a lot more management underlying the data service. This is going to be a single database. It's not going to be multiple databases within a server as you might be expecting with other SQL servers where you would have multiple SQL databases. New features in Azure SQL Database are introduced here first and then make their way to other versions of SQL Server later. Azure SQL Database is located in 38 data centers globally. You can put your SQL Server close to your users that way. You have no access to the servers behind the scene. Azure takes care of all that management. Also, there are no SQL Server agents. Azure SQL Database is best for new projects. Now, I've been involved with a group that's doing migrations to Azure, and we look at a lot of database and applications that would be migrated to the cloud. And it's very rare that we have just a simple single database that only uses the options available in the Azure database. If you're building an application starting in the cloud and using the other cloud components, as opposed to using things that are built into the full-blown SQL Server in on-premises version or in on a VM, then we could take a look at it. We do have a migration assistant that can analyze your on-prem or cloud databases for suitability with Azure SQL Database, but experience has shown that it's fairly rare that you'd have to rewrite your application or rewrite your database quite extensively. So think about this mostly with new projects. Azure SQL Database has dedicated resources in the cloud, and those resources can be scaled up or down manually. You can create elastic pools for your Azure SQL Database, and with this option, you pull multiple databases which share a set of resources in the elastic pool. And then you would get auto-scaling within those resources. So say one database was busy at one time of day, a different database was busy at a different time, then they could auto-scale up and down to make best use of the CPU and the memory and the throughput within that pool. So it'll smooth out resource usage and also billing. We have general purpose standard versions for lower resource consumers, and then business critical and premium for more critical, higher resource needs. The premium tiers have 3 replicas that are allocated automatically when you create the database. They have higher I/O limits and lower latency guaranteed. Then we also have a hyperscale, which are even bigger, faster, more resource intensive machines. Once you're in a managed instance, it's easy to move from one level machine to another and back. When we get to Synapse servers, we have serverless option, which is where there's a resource pool available, but it's not a specific number of servers. It's just a massive compute tier that also has auto scaling. A SQL Server managed instance is made to fill the needs in between SQL Server on a VM and Azure SQL Server Database. The managed instance combines SQL Server Database engine compatibility with the benefits of a fully managed platform in the cloud. It keeps compatibility with the latest SQL Server Enterprise Edition database engine. It's meant for many legacy on-prem databases because it reduces the option because you still don't have access to this Windows server underneath the platform that's managed by Azure, but you have more manageable control over the actual SQL Server. You get automated backups, configurable retention, high availabilities to 4 nines guaranteed with the managed instance. Each instance can host multiple databases, so in that way it's more like what DBAs are going to be used to from SQL Server. And also existing server licenses from on-prem can be transferred to be used with the SQL Server managed instance to save the cost of the upgrade. SQL Server managed instance has point-in-time restore capabilities. That would be like having the transaction log set to full mode with the handling of those logs managed for you in the managed instance. We have encryption at rest, encryption in motion, encryption during processing with the auto-encrypted options, with the always encrypted options. Managed instances uses Azure Active Directory authentication for simplified authentication. It has SQL auditing as an option, We can also specify either general purpose or business critical tiers depending on your workload needs, as we mentioned earlier. As of November of 2021, instance pools for SQL managed instances was available in public preview. Generally, new options come to wide availability in the commercial cloud first and then to government cloud tiers later. So it could be a few months before this becomes available in the government clouds, but it's important to know it's on the way. This option would be where multiple instances reside in the same virtual machines in the cloud, and you can still don't have access to configure those virtual machines, but you would be able to configure how many virtual machines and how powerful machines are used. You would also pre-provision those resources that would be shared amongst the multiple instances and the databases that live on each of those instances. You have some of the most modern hardware available, so between 2 and 80 cores and up to 2 terabytes of storage. You can add up to 100 users per database instance, and there's still no SQL Server agent, so if you're dependent on having a SQL agent, you're really going to be limited to IaaS SQL Server. And that's it for this part of the Azure Data Technology Summary. The next part will cover more database options, analytics, and we'll move on from there to all the other options. Thank you for listening.